Greetings everyone. Welcome to the orientation lecture of the second term ISC Psychology project. The name of the project topic is Statistics. Now, in this video, I'm going to demonstrate all the steps that you guys have to do in order to complete this project. Also, we will be discussing the writing part of the project along with the graphs. So I request everyone to watch the full video and not to skip any steps. So these are all the topics that we are going to discuss in this video. It starts with certificate page and cover page, followed by index, aim, basic concepts, methods, results and discussions, conclusions, and appendix. Now we are going to discuss all these topics one by one in detail. So let us start with the first topic, and that is the certificate page. So just like your attitudes project, this project also starts with the certificate page, which will be attached by the school once you submit the hard copy of your project in a white transparent file. After the certificate page, the next page of your project is going to be the cover page. Now I will be sending the template of the cover page to you. You will have to edit the cover page accordingly. So insert your details and delete the things which are not applicable to you, and make sure you do not change the font size, font type, page alignment, and page orientation, as the cover page is standardized for everyone as per the council's requirement. Now the third page in your project file is going to be the index page, and it should look exactly like this. Now you don't have to type it. The index page should be handwritten. In fact, all the pages after the cover page are going to be handwritten. So as you can see, the index page, the list of the topics and their order is similar to the attitudes project. So now let us start by discussing each of these topics in detail. So the first topic of your index is the aim of the project. And the aim is to study group differences in examination results. Now the aim is written in the project guidelines and you can directly copy from it. So you will be writing the aim at the top or the center of the page, and rest the entire page will be blank. It's same like attitudes project. Now moving on to the second topic, and that is basic concepts. So these are all the topics that you are going to write as a form of introduction to your project. Now make sure you write each and every topic mentioned here. Okay, elaborate it, mention the formulas wherever it is required, state the uses, types, advantages, disadvantages accordingly. And there is no page limit for basic concepts. But as per my experience, writing all these topics should roughly go around 15 to 20 pages. Now coming to the most important question, and that is exactly what you have to do in this project. Well, we are going to analyze the examination marks of the students. But then the second question arises, exactly how are you going to do it? In what way are you going to do it? So let us now look at what is this project about and what all things you have to do in order to complete it. So the very first thing that I am going to do is I'm going to give you a data of total 50 students from grade 10 randomly. Now out of these 50 students, 25 students belong to one division and 25 students belong to the other division. And this data is nothing but their marks obtained in the mathematics subject out of 100. So the sample size of this project is going to be 50. And the sampling method that we are going to use is random sampling. Now how the data is going to be distributed. So we have total 90 psychology students in ISC this year. And I am going to randomly divide you guys in the groups of 30 students per group. And I will be sending different set of data to each of the groups. So for group 1, there will be 30 students and I will be sending data set 1. So this data set 1 will consist of marks of total 50 students, that is students belonging to division A and B, and a Z table. Same way for group 2, they will receive data set 2. It will consist of marks of total 50 students belonging to C and D division and a Z table. And same way for group 3, they will receive data set 3 and marks of total 50 students belonging to E and F division along with the Z table. Now, what is this Z table? That we will discuss later on in this video. Now, I have the record of all of you and I know which student is going to use which data set. So please don't try to exchange the data set with each other. So we are going to compare the scores of mathematics between division 1 and 2 and then try to find out which division has performed better by calculating the central tendency, that is mean. Also, we are going to find out the percentile scores of 4 students, that is 2 from each division, using the standard deviation and Z table. And then we are going to identify how many percent of students in the class have scored the marks above or below them. And then we are going to plot these percentage of scores on the normal distribution graph. So these are all the things that we are going to do in this project. So summarizing the previous slide, there will be total 2 types of analysis that we are going to do. The first one will be the group analysis and the second is the individual analysis. Now in group analysis, we are going to compare both the divisions with each other by calculating the mean score to see which division has performed better. And then we are going to compare variance and standard deviation to indicate how the scores are spread from the mean. And in the individual analysis, we are just going to calculate the Z score of total 4 students. So what exactly is this Z score? So a Z score is a number that describes the position of the raw score in terms of its distance from the mean. So this Z score indicates the area under a standard normal curve and is measured in standard deviation units. So a Z score will be positive if the value is above the mean and the Z score will be negative if the value is below the mean. Now there is a formula to calculate this Z score. So this is a formula that we use in statistics to calculate the Z score. The formula is x minus mu divided by sigma, where x represents the individual raw score, mu represents the mean of that particular group, and sigma stands for standard deviation of that particular group. Now, in the previous slide, I had made a statement that when this individual raw score is more than the mean of the group, then the Z score is always positive. So for example, if the score is 75, mean of the group is 50 and standard deviation is 10. Now let's try to calculate the Z score by using the formula. So 75 minus 50 divided by 10, the answer you get is 12.5. So you see the Z score is a positive number. On the other hand, if this individual raw score is less than the group's mean, then the Z score is always negative. So for example, the individual score is 35. Again, the mean is 50, standard deviation is 10. And if you apply the Z score formula, 35 minus 50 divided by 10, the answer you get is minus 7.5. So this is very important for you guys to remember that whenever the individual raw score is more than mean, then the Z score is always positive. And when the individual raw score is less than mean, the Z score is always negative. So let us now quickly look at the list of all the calculations that we are going to do in order to complete the project. So the list looks something like this. As soon as you get the data from me, we are going to calculate the mean of both the divisions. Then we are going to calculate the variance of both the divisions. Then we are going to calculate standard deviation of both the divisions. And then we are going to calculate 4 Z scores. Now, for calculating the 4 Z scores, we are going to select 2 students from each of the division. Now there is a criteria for selection. So when you're going to select 2 students from division 1, we have to select one student whose score is above the mean and one student whose score is below the mean. Same way we have to repeat it for division 2 as well. So one student whose score should be above the mean and the another student score should be below the mean. And then we are going to convert these 4 Z scores into a percentage using standard normal distribution table that I will be attaching in the data sheet, which I will send it to you. And then we are going to calculate these 4% onto a standard normal distribution graph. So these are all the things that we are going to do in order to complete the project. Now it may look overwhelming, but trust me, it's going to be very easy. Just follow the steps that I am going to show in the video and you will be able to complete the project in no time. So when you will receive your data sets from me, this is how it's going to look like. It consists of an Excel file with 3 sheets attached in it. That is division A, division B, and SNDT. That is the standard normal distribution table. Now, as you can see over here, the first column indicates the student name, and I have replaced their names with numbers to avoid any potential biases. The second column includes their marks that they have scored in mathematics out of 100. Now, for the demonstration, I have selected only 15 students, but you will receive a data of total 25 students per division. Okay, same thing with division B. Okay, so 15 students I have selected over here. And the third sheet is going to be a standard normal distribution table. So this is how the table looks like. It starts with 0 and ends at 3. Now all these numbers inside the table represents the area under the normal distribution curve. So we are going to use these numbers in order to calculate our z-score and to convert the z-score into the percentage score. So that's how the data is going to look. Now what we are going to do is we are going to arrange our raw data in a very systematic manner, and we are going to add up some columns with respect to all the calculations that we are going to do in this project so that it looks more systematic and it looks more nice when you take a printout of that. And it also helps us in keeping a track of all the calculations that we are doing. So now let us arrange our data in a more systematic manner. Now, in order to do that, what you do is you add a new Excel sheet into this file. So just simply click on this plus icon over here and a new Excel sheet will be added, and simply rename it as calculations. You can rename it to it whatever you want. That is not important. So I have renamed it as calculations. Now what I'm going to do is I'm going to copy paste the scores of both the divisions into this Excel sheet. So as you can see, I have copied the scores of both the divisions into this Excel sheet. And now I'm going to add the columns for all the calculations that we will be doing in the project. So now the first 3 things that we will be calculating with this data set is going to be the mean, variance, and standard deviation. So I will simply mention it over here. After that, we are going to calculate the 4 z-scores, 2 students belonging to each of the division. So I will simply write here z-scores. After calculating the 4 z-scores, we are going to look at their standard normal distribution value in the standard normal distribution table. So I will write here SNDT values. Now because we have 4 z-scores, we will have 4 SNDT values. And after this, we are going to convert these 4 SNDT values into percentage. So I will write here percentage. So all our columns are ready and also the data is arranged in a very systematic manner. Now you can also put colors to these columns so that it looks more nice. But make sure you do not use too vibrant colors, because when you are going to print this Excel sheet, the numbers you put inside it should be visible. So our data sheet is ready. And now we are going to start with the calculations. So let us now begin with the first step in our list of calculation, and that is calculating the mean, of both of these two divisions. So we are simply going to put the formula over here. So the formula for calculating mean is, I will write average bracket open, then select all the students' marks from division A and simply press enter, and you will get an average score over here. Same way we have to do it for B class. So I will again put is equal to average bracket open. I will select the marks of all the students from division B and I will press enter. So like this, I have calculated the average of both the classes. So remember, the Excel formula for calculating mean is equal to average and selecting the entire column. So the mean of division A is calculated to be 71.13 and the mean of division B is calculated to be 75.73. Now, as you can see from both the mean scores, that division B has performed better. Now let us move on to the next calculation, and that is calculating the variance of both these divisions. So the formula of variance looks something like this. So variance is indicated by S square, and the formula is summation of x minus x bar the whole square divided by n minus 1. Now what we are going to do is we are going to break out this formula into different parts, and we are going to do the calculation of each of these parts in Excel. So the formula looks something like this once you break out. So it is x minus x bar, which is this part you see over here in the formula. Then that is x minus x bar the whole square, then summation of x minus x bar the whole square, and then the n minus 1. So we are going to do each of these 4 steps into Excel one by one in order to calculate the variance of our data. So coming back to our Excel sheet, now let us start by calculating the variance and the first step in the formula, that is calculating x minus x bar. So before that, let me just set up few things over here. So basically I will give the title to the columns, that is A and B division, and the name of the column will be x minus mean. This will be for division A, then x minus mean for division B, and I will simply put it to center. Okay. Now what we are going to do over here is we are going to subtract each of these scores from the group's mean. Same way for division B, we are going to subtract each of these scores with the group's mean. So the formula in order to do that is simply just click on this column, put is equal to, select this score because we are going to subtract this, add the minus sign on your keyboard and select the mean cell where you have inserted your mean. Just select that cell. Now what you have to do is, and this is very important, you just have to put a dollar sign between this C and 20 so that we will freeze this cell across all these columns. So what we will do is it is C4 minus C $20. So if you do this and press enter, you will get the value if you subtract 67 from 71.13. Then just simply drag all these columns till the end. So you have subtracted all the scores from division A with its mean value. Same thing you will have to repeat it for the mean. So again I will put is equal to, select the first score over here, minus I will select the group's mean and I will put a dollar sign over here in between and I will press enter and I will get the number after I subtract 89 from 75.73, and then I will just drag this and I will get the values of all these scores when I subtract them from the mean. So this is the first step of our formula. So we have completed the first step of our formula, and that is calculating x minus x bar, where x indicates the individual raw score of each participant and x bar indicates the mean of the group. And now we are moving on to the next stage, that is calculating x minus x bar the whole square. So we are simply going to square the values that we have obtained from the first step. So coming back to our Excel sheet, I have already made two columns A and B where we are going to do the second step of our calculation. So I will simply name this step as x minus mean the whole square. Same way, I will name it for column B as well. Now, why we are squaring these numbers is because, as you can see, there are negative values over here. So in order to remove that negative values, we are going to square this. So what we have to do over here is the formula for squaring is simply press is equal to, select the first value over here from division A and simply press shift plus 6 and you will get this upward arrow and press 2 and then press enter and you will get the square of this number. Then select this and just drag below. So you will get the squares of all of these numbers. Same way, repeat it with division B. So again, I will put is equal to, select the first number and then press shift plus 6 and then 2 and press enter and you will get a square of this number and simply drag it below. So this is the second step where we have done the square of all these scores. Now let us move ahead with the third step in our formula for calculating variance, and that is summation of x minus x bar the whole square. So this simply means that whatever calculation we have done in step number 2, we are simply going to add all these numbers for both the divisions. So it's a pretty easy step. So let us go back to our Excel sheet. So with respect to the third step, as the formula suggests, it is summation of x minus x bar the whole square. So we have already calculated x minus x bar the whole square in the second step. And when the summation sign is added, it simply means that we have to add all these numbers for both the divisions, that is division A and division B. So in order to do that, just select any two columns. Okay, so I have selected these two columns at the bottom. Press is equal to, the formula is sum, S-U-M, bracket open. Select all the scores of division A and press enter. So this is the total that you get for division A. Same way, we will be doing it for division B. So again, I will select this column. I will press is equal to sum, bracket open, and select all the scores of division B and I will press enter. So we get two total scores, and that is summation x minus mean the whole square. So that is step number 3. So now let us move to our last step in calculating variance, and that is dividing the summation x minus x bar the whole square by n minus 1. Now here n indicates the number of sample in each group. So let us do the calculation in our Excel sheet. So in order to calculate the last step of variance, we just have to divide this number, that is summation of x minus x bar the whole square, by n minus 1. Now in our data, since I have selected total 15 participants, so my n will be 15 and n minus 1 will be 14. But in your data that I will be sending you, you have got data of total 25 students. So your n will be 25 and your n minus 1 will be 24. Now since we already know the value for n minus 1 and also we have the value of summation x minus x bar the whole square, simply what we have to do is we have to divide and we will get the variance of both of these divisions. So in this column variance, I will simply write is equal to, the formula is summation x minus x bar the whole square. For division A, the value is 3149.73. So I will select this cell and I will simply divide, put an oblique sign and type 14 because my n minus 1 is 14. For you, it will be 24 and I will press enter. And here is the variance of division A, that is 224.981. Same way I will do it with B division as well. So I will put is equal to, select the score of B division, put an oblique sign, that is a division sign, divide by 14 and I will get the variance for the second group and the variance is 139.20. So this is the variance for both the divisions A and B. Okay, so we have completed calculating the variance score of both the divisions. Now, just in case if you want to check whether your values are correct or incorrect, there is a direct way to calculate the variance as well. That is, there is a direct formula in Excel where you can calculate the variance of that entire group. So you don't have to do all these calculations that we did. And let me just quickly show you the formula. The formula is equal to VAR dot S bracket open and just select all the scores of division A and press enter. So you can see the value that you obtained over here, that is 224.98, is similar to the value that we have calculated over here by doing all these steps. Same way I will do it for division B, is equal to VAR dot S and I will select all the scores of division B and I will press enter and the value is again similar, 139.20, 139.20 over here as well. But what is the reason why we did all these calculations when we have this alternative way of just simply putting a formula and obtaining the variance score? Well, the reason is by doing all these calculations, we are showing the external examiner that we have actually worked out on our data. So all these numbers are like a proof that we have actually done the calculations. We have actually worked on this data. That's the only purpose why we are going in so much of details. So that is the steps on how to calculate variance, and that is a direct formula on how to calculate the variance. Now we are moving on to the next step, that is calculating standard deviations. So let us move on to the next step in our list of calculations, and that is calculating standard deviation. Now, calculating standard deviation is very simple because standard deviation is nothing but the square root of the variance that we have calculated. So we have already made two columns to input the standard deviation values of both the divisions. So just simply click on this column and the formula for calculating standard deviation is basically square root. So I will simply type SQRT bracket open and select the value of variance that you have calculated and press enter and you will get the standard deviation of division A. Same way we will do it for division B. I will press is equal to, formula is SQRT bracket open, select the value of variance of division B and press enter. So as you can see, for division A, the standard deviation is calculated to be 14.99 and for division B, it is 11.7. So now let us proceed to the next step in our list of calculations, and that is calculating the z-score of total 4 students. Now we are going to select 2 students from division A and 2 students from division B, and will calculate the 4 z-scores. Now the selection criteria of these 2 students is one student score should be above the mean and another student score should be below the mean. So let's say, for example, from A division, I am selecting a student whose score is above the mean. So my mean value is 71.13. So I have to select one student whose score is above the mean. So I am selecting this student whose score is 78. Okay, so 78 is greater than 71. And again, I have to select one more student from division A whose score is below the mean. So I am selecting this score 62 because 62 is less than 71. So like this, I have selected 2 students from division A. Same way, I will be selecting 2 students from division B. So the mean of division B is 75.73. So I will select the first score 89, that is the score above mean, and then I will select another student whose score is below the mean. So I will select the number 69 over here. Now I will have to calculate the z-scores of these 4 students. So this is the formula for calculating the z-score, that is x minus mean divided by standard deviation. Now we have calculated all these values on our Excel sheet. So let us just apply the formula and do the math. So we have already made columns where we are going to input our z-scores. So simply select the first column where we are going to input the 2 z-scores of division A. In the first column, we are going to calculate the z-score of the student above the mean. So I will simply write the formula is equal to bracket open x, that will be the value above the mean, that is the individual score, minus the mean of the group, that is 71.13. So I will select this cell, I will close the bracket, I will put a division sign, and I will divide it by the standard deviation, that is 14.99. So I will simply select this cell again, and when I press enter, I will get a z-score, and that is 0.457797. So this is a z-score for your first participant. In similar way, you have to calculate the z-score for your second participant whose score is below the mean. So again, I will simply write is equal to bracket open, select the score, that is x, minus the mean, that is mu, bracket close, divide by standard deviation will be the same. And when I will press enter, the z-score will be minus 0.60. So in the same manner, I will calculate both the z-scores for the B division as well. So as you can see, I have calculated all the 4 z-scores, and you can observe it over here that when the individual score is greater than mean, then the z-score is always positive. But when an individual score is less than mean, then the z-scores are always negative. So the next step after calculating the 4 z-scores is that we have to determine where our 4 individual scores lie inside the standard normal curve. So these 4 z-scores are going to help us in determining the area under the normal curve where our 4 scores lie. So we are going to use the standard normal distribution table here to determine the area under the normal curve. So follow the steps carefully here, and this is going to be very important. So let's say, for example, I calculate a z-score and the score is 0.74529. And I want to determine the area inside the normal curve corresponding to this value. So how to do that? So what we have to do is we have to focus on the first 3 numbers of the z-score here, and the first 3 numbers over here is 0, 7 and 4. Now the second step over here is we have to select the first 2 numbers, and here it is 0.7, and then you will have to search for this 0.7 under the Z column vertically. So let me show you how to do that. So this is the standard normal distribution table that I have attached in the Excel file. Now, as you can see, these are all the Z values starting from 0 and it goes up to 3. Now here we have to search vertically for 0.7. So 0.7 is over here. So we have reached up to 0.7. Now let's move on to the next step. So next what you have to do is you have to simply focus on the third number in the Z score. And here the number is 4. So what you do is simply look around for 0.04 horizontally across the table. So coming back to our SNDT table, now we have already looked for 0.07 and now we have to search horizontally and go up to 0.04. So you see this orange line over here, 0.04 is over here. So corresponding to 0.07, we will go up to 0.04 and the number we reach is 0.2704. So this number is your area of that particular individual score under a normal curve. Now, let's say for example, the third number in the Z score is 6. Then you would have searched for up to 0.06. If this number is 8, then you could have searched up horizontally up to 0.08. So whichever the third number is, you will just have to add 0.0 and that number and search horizontally across the number. Let us look at one more example with respect to a negative Z number. So here in this example, the Z score obtained is minus 2.3180. So the first step is focusing on the three numbers of the Z score. Irrespective whether it is a negative number or a positive number, that doesn't matter because the normal curve is symmetrically distributed. So the area on the left and the right hand side of the normal curve is going to be same. So here the first three numbers are 2, 3 and 1. Now what we have to do here is focusing on the first two numbers, that is 2.3. So what we have to do is look for row 2.3 in the table. So look for 2.3 vertically under the Z score. So let us have a look at the table. So coming back to our SNDT table, now we will go vertically and search for 2.3. So 2.3 is over here. Okay. And now what is the third number? We will search horizontally across the table for that. So the third number over here is 1. So we will read along until 0.01 horizontally. So let's see what is the value that we reach. So 2.3 and 0.01 is the second column. So you see 0.01 corresponding to 2.3. The number is 0.4896. So this is the area of the second individual score under the normal curve. So here I have written the areas below. Now in the same way, let us find out the area for our 4 Z scores using the SNDT table. Okay, so coming back to our calculation sheet, the 4 Z scores that we have obtained by calculating is 0.4578. This is the first Z score. Second is minus 0.60891. Third Z score is 1.12442. And the last Z score is minus 0.57068. Now let us find out the area for all of these 4 scores. So let us take into consideration our first score, that is 0.4578. So like I said, you have to first focus on the first 3 numbers. So over here, the first 3 numbers are 0, 4 and 5. So in the SNDT table, we first have to search for 0.4. So under the Z column, go up to 0.4.
4. The next number is 5, the third number. So we will search up to 0.05. So 0.4 go corresponding up to 0.05. The score we reach is 0.1736. So what I will do is I'll simply copy this value over here into our SNDT value. So the value is 0.1736. Same way, I will do it for the next score, that is minus 0.60891. So the first three numbers over here is 0.6. So in our SNDT table, search for 0.6. Go up to 0.6 vertically. And the third number is 0. So here we will go up to 0.00. Okay, or just 0, which is the first column itself. So the number is 0.2257. So just simply copy it and paste it over here in the SNDT value. Okay, so that is a number that we have received. So same way I will do it for the B division as well. So the Z value over here is 1.124417. So let us focus on the first two numbers, that is 1.1. So in the SNDT table, search up to 1.1. After that, the third number is 2. So we will go up to 0.02 horizontally. So 1.1 and go up to 0.02 horizontally. The number is 0.3686. So I will simply copy this number and paste it over here. And the last Z score is minus 0.57068. So the first two number is 0.5. So in the SNDT table, go up to 0.5 and the third number is 7. So we will search horizontally up to 0.07. So we will go directly up to 0.07 and the area is 0.2157. So simply copy this and paste it over here. So we have found the area of all our 4 participants in a normal curve corresponding to their Z scores. And the next step is now we are going to calculate the percentage.
So the next step is converting the SNDT value into percentage. And this is pretty simple to do. So how to do it? Let's say, for example, the SNDT value that you have obtained is 0.2704. Now, in order to convert it into percentage, we just have to look at the 4 numbers after the decimal point and just put a decimal point after 2 numbers. So here the percentage would be 27.04. So as you see, this number 2704 is same 2704, but I have just put a decimal point and that is your percentage. Same way, another example, if the SNDT value is calculated to be 0.4896, once you convert it into percentage, it will become 48.96%. So now let us do this for our 4 SNDT values. So coming back to our calculation table, the 4 SNDT value that we had found using the SNDT table were this. Now let us simply convert them into the percentage. So the first value is 0.1736. So simply it will be 17.36%. The second value is 0.2257. So simply it will be 22.57%. The third value is 0.3686. So it will be 36.86%. And the last value is 0.2157. So it will be 21.57%. So now basically we are done with all our calculations. And the next step now is we have to start plotting this percentage score onto a normal curve. So let us start by plotting the percentage score for each of the 4 participants on a normal curve. Now I have already drawn a normal curve on a graph paper which looks something like this. It's symmetrical on both the sides. And on the x-axis, as you can see, I have written numbers from 10 to 50 on the right hand side of the normal curve. And on the left hand side, again, I have written numbers starting from 10 up to 50. Now these numbers represents percentage. So it is 10%, 20%, 30%, and so on the right hand side, and 10%, 20%, 30%, so on the left hand side. Now the scale that I have used over here is 2 centimeters is equal to 10%. So I have kept a gap of 2 squares between each of the percentage score. Now you are going to draw a normal curve exactly like this. So before we start plotting the percentage score onto this normal curve, let me tell you some facts about this normal curve, and these things will help us in doing our further calculations. Okay, so as you can see that the normal curve is divided into two equal halves by the mean at its center. So whichever mean value you calculate will always divide a standard normal curve into two different halves. That is, the mean will always be the center of the standard normal curve. Now the entire area of the standard normal curve will always be 100%. So I will write here 100%. Now because the mean is dividing the standard normal curve into two equal halves, that means on the left hand side the area is going to be 50%, and same way on the right hand side the area of the normal curve will be 50%, because half of 100 is 50. So it is important for you guys to understand this, because we are going to use these numbers for further calculation. So one more important thing that you should keep in mind is any score falling on the right hand side of the normal curve is always positive, and any score towards the left hand side of the normal curve is always negative. Now how to apply this logic while plotting our percentage score into this normal curve? So you know that we have calculated the z-scores for 4 participants. That is, we have selected 2 students from each of the division. Now we have converted these z-scores into the corresponding percentage scores by using the standard normal distribution table. Now we are going to calculate this percentage score onto the normal graph. So we need to focus on the 4 z-scores. So if the z-score is positive, then you will plot the corresponding percentage score onto the right hand side of the normal curve. And if the z-score is negative, then you are going to plot the corresponding percentage score onto the left hand side of the normal curve. To simplify it more for you guys, just remember, out of the 4 students, the 2 students who are scoring above the mean, their percentage score will be plotted on the right hand side of the normal curve, and the 2 students who are scoring below the mean, their percentage score will be plotted to the left hand side of the normal curve. So let us plot their percentage score now. Okay, so just for my reference, I have written down the values over here. So the first score that we are going to plot on the normal distribution curve is the score of the first student from division A who has scored above the mean. So the score that we selected was 78. The corresponding z-score that we calculated was 0.4579, and the percentage score corresponding to this z-score was calculated to be 17.36. Now we are going to plot this 17.36 onto this normal graph. So as you can see that the z-score is positive, that means we are going to plot this 17.36 onto the right hand side of the normal curve. So let us plot 17.36. So 17.36 will lie somewhere between 10 and 20. So it will be somewhere over here. And I will simply mark this as X so that it indicates that this is my score that I have plotted. And I will simply write here the number 17.36. That means this is the percentage of area which is from mean to the value X. So this area indicates 17.36%. So we have plotted the first score. So after you plot the percentage score, there are few set of questions that you will have to answer. Now these questions are the part of the conclusion of your project. So let me show you what these questions are. So these are the 4 questions that we are going to answer with the help of our normal curve. So let us look at the first question. That is, what percentage of students lie between the mean X bar and the individual score X? That is, we have to find the percentage of students from mean up to the individual score that we have plotted X. So coming back to our graph. So basically we have to find the percentage of students lying between this area of the normal curve. So from mean to the X. Now we have already calculated this percentage and the answer will be 17.36% of student. So I will simply write the answer over here, and that is 17.36%. Now let's go to the second question. That is, how many percent of students score lie at the tail of the distribution? Now what do you understand by the word tail of the distribution? So in a standard normal curve, the tail is the area towards the end of the normal curve. So a standard normal curve has 2 tails, one on the right hand side, another one on the left hand side. Now because we have plotted our score to the right hand side, we have to calculate the area of the right tail of the normal distribution curve. So basically the area that we are going to plot is this area in the normal curve. After you plot the percentage score, whatever area remains will be called as the tail of the distribution. Now how to do the calculation? Now we know that this entire right hand side covers the area of 50% and the area from mean to X is 17.36%. So what you do is simply subtract 17.36% by 50. Whatever answer you get will be the percentage area at the tail of the distribution. So the answer you get after subtracting is 32.64%. Answering our question, how many percent of students score lie at the tail of the distribution? The answer will be 32.64%. So now let us move on to our third question, and that is, how many percent of students are scoring above the selected student? Now, what does this question mean? So we have selected a student who has scored 78, and then we have plotted the corresponding percentage score over here on a normal graph. So we have to find how many percentage of students are scoring above 78 marks. So if we have plotted this student, the selected student score over here, then the students who are scoring above him will lie onto this area of the normal curve. That is beyond this area of the normal curve. So we have to find the area of this portion of the normal curve in order to answer our question. So we have already found the area, and that is 32.64%. So the answer to our question is the percentage of students who are scoring above the selected student is 32.64%. Okay, so let us move ahead now with our last question, and that is how many percent of students are scoring below the selected student. So coming back to our normal graph, so we have plotted the individual score over here, and this right hand side area that is beyond the individual score indicates the percentage of students who are scoring above him. So this area towards the left hand side will automatically will indicate all the percent of students who are scoring below this person. So in order to answer this question, we have to calculate the area of this part of the normal curve. So we know that the entire area on the left hand side of the normal curve is 50%. And we also know that the area from mean to the individual student score is 17.36%. So in order to calculate the area of all the students below the selected student is you just have to add 50% with 17.36%. So the answer to this question is, so the area calculated will be total 67.36%. So that means 67.36% of students are scoring below 78. So now let us write the answer. So the percentage of students who are scoring below the selected student is 67.36%. So now let us plot the second graph, and this time the student's score is below the mean. So the score of the student is 62. The calculated z value is minus 0.60891 and the corresponding percentage score is 22.57%. Now we have to plot this 22.57% onto this normal curve. So if you round up 22.57%, it becomes 23%. So we have to plot 23%. Now this 23% will lie onto the left hand side of the normal curve because our z score is negative. So whenever the z score is negative, we plot the number towards the left hand side of the normal curve. So 23 will be over here. And I will simply name this as X because this is the score that we have plotted. So we have finished plotting the score, and I will simply mention it over here that the area from mean up to the score is 22.57%. Now let us solve the 4 questions again. So the first question is, what percentage of students lie between the mean x bar and the score x? Now the answer to this question is 22.57% because that is the area that lie from the x to the mean or from the mean to the x. So the answer to this question will be 22.57. Moving ahead with the second question, that is how many percent of students score lie at the tail of the distribution. So as we have studied earlier, tail indicates the ends of the normal curve. But because we have plotted the score to the left hand side, so we will be calculating the tail towards the left hand side. So we are going to calculate this area. So beyond the score, whatever area will be there indicates the tail of the normal graph. So as we know that this entire left hand side is 50%. So what we will do is we will simply subtract 22.57 from 50%. And the answer that you get, that will be the tail. So the answer to this question will be 27.43%. I will also write this over here. that is 27.43%. Moving back to our third question, and that is how many percent of students are scoring above the selected student. So we have plotted the student score over here. Now, students who are scoring above him will lie on this side of the normal curve. So we know that the entire right hand side of the normal curve is again 50%, and the area from the student score to the mean is 22.57%. So in order to answer this question, we have to find the area of this part of the normal curve. So these are all the students who will be scoring above this individual student. So what we have to do is we have to simply add 22.57 plus 50%. And the answer that you get will be the percentage of students scoring above this individual. So the answer to this question will be 72.57%. And I will also write it over here, that is 72.57%. So this indicates all the students who are scoring above this individual. Now moving to our last question, and that is how many percent of students are scoring below the selected student. So if these are all the percentage of students who are scoring above this individual, then these will all be the students who are scoring below him. So the answer is 27.43%. We have already calculated the area. So the answer to this question will be 27.43%. So we have calculated two graphs for two students belonging to division A. Now same way, you have to calculate the graphs for the other two students belonging to division B. So the total number of graphs that you will plot will be 4. And there is one more additional graph for the group analysis. So the last graph that we are going to draw is with respect to the group analysis. Now we are simply going to plot the mean scores of both the division and make a comparison that which division has performed better. I have already written the mean scores of A division and B division taken from the calculation sheet. Now I simply have to plot these two scores onto a simple bar graph. So I have already drawn the bar graph, and first I will plot division A, that is 71. So 71 will go up to here. And I will simply mention it over here, division A. And the next mean value of B division is 75.73. That means 76. So 76 will be over here. And I will write it over here, division B. So as you can see, division B has performed better than division A. So these are all the graphs that you are going to plot. So total there are 5 graphs, 4 graphs of normal distribution curve and one simple bar graph plotting the means of both the group. Okay, so now let us move on to the third major topic in our project as per our index, and that is methods. Now under methods, we have total 4 subtopics, that is sample, procedure, treatment of data and graphs. So let us discuss each of these topics in detail and exactly what you have to write in these topics. So the first topic is going to be sample. So your sample should look something like this. Now you can pause the video over here and you can just read this slide. What I'm going to do is I'm going to send you a template of this so that it would be easier for you to edit and copy directly in your project. So the next subtopic is the procedure. So The procedure should look something like this. And you can again pause the video over here and just read through the slide. Again, I'm going to send you a soft copy of this, a template of this, so that it would be easier for you to refer. This is the continuation of the procedure. So again, you can pause the video over here and just read. Now, the third important topic, that is treatment of data. Now for treatment of data, what you have to do is you first have to attach the printout of the calculation sheet. So wherever we have done all the calculation on the Excel sheet, take a printout of it and attach it over here under treatment of data. Next thing what you have to do after attaching the calculation sheet, you have to mention the formula. You have to write the formula of mean, variance, standard deviation, and z-score. Now all these formulas are given in the guidelines. So straight away you can copy it from there. And the last thing that you have to do is write the percentage scores calculated for the z values. So just draw one small table like you have drawn on the Excel sheet and just mention the values in treatment of data. Next thing after treatment of data is graphs. So we have drawn total 5 graphs and you have to attach all the 5 graphs over here. So out of 5 graphs, 1 graph indicating the mean score of both the groups, and there is 4 graphs which indicates the percentage scores on the normal distribution curve. So this was all about the third major topic, that is methods. Next, moving on to the fourth major topic as per our index, and that is results and discussion. Now under results and discussion, you first have to draw the 4 result table shown in the project guidelines under the results and discussion section. So let me just show you which tables you have to draw it over here. So these are the tables that I have mentioned in the guidelines. And as you can see, there are total 4 tables. And these 4 tables are for the 4 students that we have selected in order to calculate the z-score. So as you can see, table 1 is of individual analysis and student scoring above the mean. So you will have to fill in all these details over here. So the first column is grade and section, so that we don't know, so just leave it blank. Next column is final examination score. So whatever score the student has got, you can fill it over here. The mean of the group, that is division A, the standard deviation that we have calculated, and his z-score. You have to write it over here, and the percentage unit. Same way for the second student, okay, individual analysis of student scoring below the mean. So again, from division A, you have to fill in all these sections. Now the third table, student scoring above the mean, group 2. So that is division B. So fill in all the details over here accordingly. And same way, table number 4, student scoring below the mean, group 2 again. So again, fill in all the details over here. So these will be your 4 result table. You have to draw it with your hand and fill in all the details. All these details you will get from the calculation sheet. So copy correctly all the numbers. So after drawing all the 4 tables, you just have to write a short summary for each of the table. That is, just simply write what is a mean, what is a score that he has obtained, what is a z value, and what is a percentage score. So just summarize the table briefly. So that is about result and discussion. And now we are moving on to the 5th major topic, and that will be conclusions. So moving on to the next major topic, and that is conclusions. So for the conclusion section, you are simply going to write the answers for the 4 questions that we have solved using the normal curve. So it consists of basically percentage of students from mean x bar to x. Write the answer over here. Percentage of students in the tail of the distribution, percentage of students who have scored above the student, and percentage of students who have scored below the student. So like this, you will write these things 4 times because there are total 4 tables in the results and discussion. So for each student, you have to fill in the information for all these questions. So that will be the conclusion of the project. The next topic after conclusion is going to be bibliography. Now the examples of bibliography are already mentioned in the guidelines. So basically from wherever you have took information to write your basic concepts, you can mention that name of the book, the website, the web link in the bibliography section. After bibliography, there is acknowledgements. Now acknowledgements, basically you have to write it in third person's perspective. So you can thank over here all the people who have helped you in completing this project. And the last section is appendix, where you have to attach some documents. So what all the documents will go under appendix? The first thing will be the raw data sheet. That is the Excel sheet that I have sent you. So the scores of A and B division students. Then you have to attach the calculation sheet over here. That is where we have done all the workings, all the calculations. That printout you have to attach. And the last thing is the standard normal distribution table. So you can find all these things in the Excel sheet. So thank you so much. Hope you have understood all the steps in this project. In case if you have any doubt, feel free to contact me on the email ID. Thank you.